Hi students, have a nice day. In this section we are going to discuss about the balancing a redox reaction. How to balance a redox reaction. There are two methods. First method is oxidation number method and the second method is half reaction method or ion electron method. First of all we discuss the first method, oxidation number method. For oxidation number method, the various steps involved in the balancing process or balancing program. The first point is write the skeletal equation for all the reactants and products in the reaction. Okay, first of all we write the skeletal equation. And second point is, or second step is, identify the oxidation number for all the atoms in the equation, the skeletal equation, and also identify the change in the oxidation number. Okay, identify the oxidation number of all the atoms in the skeletal equation and identify the change in the oxidation number. And third step is determine or find the increase or decrease in the oxidation number or change in the oxidation number. If the change in the oxidation number is equal, okay, it's directly we move to the next step. But in some cases, the change in the oxidation number are not equal. In such a situation, we multiply with a suitable coefficient in order to make the increase or decrease in the oxidation number must be equal. And the fourth point is balance the atoms other than hydrogen and oxygen. Balance the other atoms except oxygen and hydrogen. And the fifth step is balance the oxygen atoms. In order to balance the oxygen atom, add H2O molecule, water molecule in the deficient side of oxygen. Okay, very simple to balance the oxygen atom. Add appropriate number of water molecule in the deficient side of oxygen atoms. And finally, the sixth step is balance the hydrogen atom. Balancing the hydrogen atom. Here we consider two medium. The first medium is acidic medium. For acidic medium, balancing hydrogen atom is very easy. Add appropriate number of H plus ion in the deficient side of hydrogen atom. Okay, in acidic medium, to balance the hydrogen atom, add H plus ions in the deficient side of hydrogen atom. In basic medium, add appropriate number of water molecule in the deficient side of hydrogen. At the same time, you add equal number of OH minus on the other side. Once again, in basic medium, hydrogen atoms are made up by or equalized by or balanced by adding appropriate number of water molecule in the deficient side of hydrogen. At the same time, you add equal number of OH minus ion on the other side. For example, if one hydrogen is deficient in one side, you add one water molecule. At the same time, you add one OH on the other side. Okay, so these are the various rules for balancing the redox reaction. Okay, a redox reaction is balanced by using these steps. The rules I give you. Then let's balance one equation. Okay, the question is balance the equation copper solid plus HNO3 aqueous gives copper 2 plus NO2 gas. Okay, this is the question. Once again I read the question. Balance the equation copper solid plus HNO3 aqueous gives copper 2 plus NO2 gas. Let's discuss step by step. Okay, the first step is write the skeletal equation. The first step is write the skeletal equation. Write the skeletal equation means copper solid plus NO3 minus aqueous plus gives copper 2 plus NO2 gas. This is the equation given. First step is our write the skeletal equations. Second step, write the oxidation number or identify the oxidation number of each atom in the equation. Okay, for that ions must be written like this. In this case, we know that oxygen is -2. So -2 into -3 -6. Out of -6, one minus is residing on the ion. So the oxidation number of nitrogen is +5. Otherwise you find let X be the oxidation number of nitrogen like that. No problem. In the side you write X plus 3 into -2 is equal to -1. X minus 6 is equal to -1. X is equal to +5. This is mental calculation. That is the proper way. If you have any doubt to calculate the oxidation number, you choose the method we already done in the previous session. Okay, let X be the unknown element oxidation number. Okay, and calculate it. Then aqueous gives copper 2 plus already in the oxidation stage, +2 oxidation stage plus NO2 gas. Oxygen -2. 2 into -2 -4. -4 is compensated by +4. And identify the change of this oxidation number. Copper oxidation number increases by 2. Okay, you write like this. Oxidation number of copper is increases by 2. So you write like this. Then oxygen -2 no change in the oxidation number of oxygen. Then nitrogen oxidation number changes. +5 to +4. That is oxidation number decreases by 1. This is reduction. This one is oxidation. Copper is oxidized, NO3 minus is reduced into NO2. Okay, so that is the second step. And the third step, if the increase in the oxidation number and decrease in the oxidation number are different, we multiply with a suitable coefficient. If the increase as well as decrease is same, no problem, you can directly go to the step 4. Okay, then here increases by 2, decreases by 1. Okay, increases by 2, decreases by 1. So LCM is 2, 1 and 2. LCM is 2. In order to make 1 becomes 2, you multiply the reduction reaction. So third step, Cu0 solids plus 2 NO3 minus. Okay, because the oxidation number change of nitrogen is +5 to +4. decrease in the oxidation number 1. But increase in the oxidation number is 2. To make equal changes, you multiply with the 2 for this reaction. Just you remember that 1 is multiplied by 2, we get 2. So change become equal. That gives Cu2 plus NO2. Okay, this is solid, aqueous, gas. You write the physical state also. Then the fourth step is valence the atoms other than oxygen and hydrogen. So here copper is balanced, 1 copper. Then 2 nitrogen, there is 1 nitrogen. So the fourth step is balance the atoms other than oxygen and hydrogen. Cu2 plus 2 NO2. Okay. Then the fifth step, balance the oxygen atom. So here 2 into 3 is 6 oxygen. Here 2 into 2 4 oxygen. So copper solid plus 2 NO3 minus gives Cu2 plus 2 NO2. How to balance the oxygen atom? Add appropriate number of water molecule. So here 2 into 3 is 6 oxygen. Here 2 into 2 4 oxygen. 2 oxygen is deficient in the right side. So we add 2 water molecule. Add appropriate number of water molecule in the deficient side of oxygen atom. So we add a water molecule. And the sixth step, finally we balance the hydrogen atom. Here hydrogen, no hydrogen in the left hand side. Here 2 into 2, 4 hydrogen. And the medium is acidic. Why? NO3. NO3 minus come from the nitric acid. Okay, nitrate. The medium is acidic. So for acidic medium, balancing hydrogen is very easy. Add appropriate number of hydrogen ion. How many hydrogen in the right side? 2 into 4. So 4H plus. 4H plus gives Cu2 plus 2 NO2 plus 2 H2O. Okay, this is the balanced ionic equation. Finally, you should check whether the equation is balanced. Copper solid, 1 mole. Here also 1 mole. 2 into 1, 2 nitrogen, 2 into 1, 2 nitrogen. 2 into 3, 6 oxygen, 2 into 2, 4 plus 2 into 1, 2. So 4 plus 2, 6. Oxygen is balanced. 4 hydrogen ion in the left side. Here is 2 into 2, 4 hydrogen. Okay, this is the various steps involved in the balancing a chemical equation. Are you clear? Yes, the second question. It is taken from the NCERT book. Write the net ionic equation for the reaction of potassium dichromate 6 K2Cr2O7 with a sodium sulfite Na2SO3 in an acidic solution to give chromium ion and the sulfate ion. Okay, once again I read the question. Write the net ionic equation for the reaction of potassium dichromate 6 K2Cr2O7 with a sodium sulfite Na2SO3 in an acidic solution to give chromium 3 ion and sulfate ion. Okay, let's discuss the various steps involved in the balancing a redox reaction. First step. What is the first step? write the skeletal equation. Okay, you remember the first step is write the skeletal equation. Cr2O7 2 minus potassium dichromate K2Cr2O7. So we take the ion, okay, Cr2O7 2 minus plus sodium sulfite. Sodium ion, that is not change in the oxidation number. Potassium also no change in the oxidation number. So Na2SO3, we write SO3 2 minus. Both are aqueous. Gives chromium 3 ion, Cr3 plus ion plus sulfate SO4 2 minus. SO4 2 minus ion. This is the skeletal equation. The first step, write the skeletal equation. The second step, identify the oxidation state of each element in the ionic equation or a reaction. Okay. Cr2O7 2 minus. The 2 minus I write in the common. Oxygen minus 2. Chromium, we don't know. Okay. So 2x plus 7 into minus 2 is equal to minus 2. 2x minus 14 is equal to minus 2. 2x is equal to plus 12. X is equal to plus 6. That is the method we studied in the previous session. Also you can calculate mentally, okay, by mental mathematics. 7 into minus 2, minus 14. Out of minus 14, 2 minus charges reside in the ion. So 2 minus, remaining is minus 12. Minus 12 is compensated by plus 12 for 2 chromium atom. Okay, minus 12 is compensated by plus 12 for 2 chromium atom. So for 1 chromium it is plus 6. If that is difficult, you know like that. Plus SO3 2 minus common. The 2 minus is common. Oxygen is minus 2. So sulfur is plus 4. Minus 2 into 3 minus 6. Out of minus 6, 2 is for the ion. Remaining minus 4. Minus 4 is compensated by plus 4. Or you do x plus 3 into minus 2 is equal to minus 2. X minus 6 is equal to minus 2. X is equal to plus 4. Both are correct. You can do any method. If you do mental mathematics, it is time saving. That gives Cr3 plus SO4 2 minus. Here oxygen minus 2, this sulfur is plus 6. Same pattern. X 4 into minus 2 is equal to minus 2. X minus 8 is equal to minus 2. X is equal to plus 6. So the third step, we calculate the change in the oxidation number. For that we write here plus 6 is changes into plus 3. Oxidation number decreases by 6 for 2 Cr atom. 1 chromium is decreased by 3. For 2 chromium it is 6. Or you can write that oxidation number is decreases by 3 for 1 chromium. For that 2 chromium multiply with the 2, it's 6. Then sulfur, the oxidation number increases by 2 units. Okay. So here decreases by 6 for 2 chromium. Here increases by 2. Then 2 and 6 different coefficients, different number. The change is different. Increases by 2, decreases by 6. So LCM is 6. 2 and 6. LCM is 6. How to make 2 become 6? Multiply with 3. Okay, so third step, multiply with a suitable coefficient in order to equalize the change in the oxidation number. Okay, so Cr2O7 2 minus, okay, plus 3SO3 2 minus. 2 becomes 6 by multiplying 3. That gives Cr3 plus SO4 2 minus. One more step, we can write the oxidation number, no problem. Plus 4, then plus 3 is there, plus 6. Oxygen minus 2, there is no change. And the fourth step is balance the atom other than oxygen and hydrogen. So Cr2's chromium is 1 chromium in the right side. So Cr2O7 2 minus plus 3SO3 2 minus gives 2Cr3 plus 2Cr3 plus 3SO4 2 minus. Why? In the left side 3 sulfur atom. To make equal number of sulfur atom, multiply with 3. And the fifth step. In the fifth step, we balance the oxygen atom. Okay, we balance the oxygen atom. So, Cr2O7 2 minus plus 3SO3 2 minus. 7 plus 9. 16 oxygen atoms. Okay, 7 oxygen plus 3 into 3, 9. Total 16 oxygen atom gives here 3 into 4, 12 oxygen atom. So what is the rule? To make up oxygen, add appropriate number of water molecule. So 2 Cr3 plus 3SO4 2 minus plus 4H2. Appropriate number of water molecule in the deficient side of oxygen. So 4 oxygen in this side. Right side there is deficiency of 4 oxygen atom. So you just add 4 water molecules. And the sixth step, balance the hydrogen atom. For balancing the hydrogen atom, the medium is acidic. In the question, the medium is given in an acidic solution. So medium is acidic. So for acidic medium, add appropriate number of H plus ion in the deficient side of hydrogen. Cr2O7 2 minus plus 3SO3 2 minus. Here no hydrogen, in the right side 4 into 8 hydrogen. So you must add 8H plus. Acidic medium, you add 8H plus. Gives 2Cr3 plus 3SO4 2 minus plus 4H2. Now the equation is balanced. Okay, let's check whether the equation is balanced or not. 2 chromium. Oxygen 7, 3 into 3, 9, 16 oxygen. 3 into 4, 12 plus 4, 16 oxygen. 3 sulfur atom. Okay. Here also 3 sulfur atom. 8 hydrogen. Here 4 into 2, 8 hydrogen. Now the equation is balanced. Okay, now the equation is balanced. So these are the various steps involved in the balancing a chemical equation or a redox reaction. Let's discuss one problem based on the basic medium. Okay, a reaction takes place in the basic medium. It is the question taken from the NCERT book. I read the question. Permanganate ion reacts with the bromide ion in basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equation for the reaction. Once again, permanganate ion react with the bromide ion in the basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equation for the reaction. What is the first step? Write the skeletal equation. Okay, first step. Easy. Balancing of a chemical equation is very easy. You just memorize or remember the steps involved in the balancing. First one is write the skeletal equation. Permanganate ion MnO4 minus. Manganese ion MnO4 2 minus. Permanganate ion MnO4 minus. Plus bromide ion Br minus. These are aqueous. Br minus gives MnO2 manganese dioxide to give manganese dioxide and bromate ion BrO3 minus. Bromate ion BrO3 minus. So first step is over. Write the skeletal equation. Then second step. Identify the oxidation number of each element in the equation as well as change in the oxidation number. Okay. So we write the oxidation number. MnO4 minus is common. Oxygen is minus 2, 4 into minus 2, minus 8. Out of minus 8, 1 minus charge in the ion. So minus 7 is compensated by plus 7. Or you write x plus 4 into minus 2 is equal to minus 2. X minus 8 is equal to minus 1. Minus 1, x is equal to plus 7. Okay. That is the method usually we do. Mental mathematics also we can apply. Br minus is already in the oxidation stage or oxidation number. Gives manganese dioxide MnO2. Oxygen minus 2. Minus 2 into 2 minus 4. Minus 4 is compensated by plus 4. Or you write x plus 2 into minus 2 is equal to 0 because the molecule is neutral. The algebraic sum of oxidation numbers of all the atoms in a neutral molecule is equal to 0. So equal to 0. X minus 4 is equal to 0. X is equal to plus 4. Same. Mental maths is also easy. Then BrO3 minus is common. BrO3 minus. 3 into minus 2 minus 6. Minus 6. Out of minus 6, 1 minus is residing in the ion. So bromine is plus 5. Minus 5 is compensated by plus 5. Or you calculate x plus bromine x. X plus 3 into minus 2 is equal to minus 1. X minus 6 is equal to minus 1. X is equal to plus 5. You do like that. No problem. Okay. To take some time. That's the matter. Then change in the oxidation number. Bromine changes its oxidation number. Oxidation number increases by 6. How? Minus 1 to plus 1. Minus 1, 0, 1, 2, 3, 4, 5. What is the change? Not 5. Some students write the oxidation number increases by 5. No. It is not from the 0. If it is 0 to 5, okay, oxidation number increases by 5. But it is start from minus 1 to 5, oxidation number increases by 6. You remember that. So please take care when you balance a chemical equation. Otherwise, your answer will be wrong. Okay. So Br minus changes into Br plus 5. The increase in the oxidation number is 6, not 5. So keep it in your mind. Then next manganese. Manganese plus 7 is changes into plus 4. Oxidation number decreases by 3. For bromine, oxidation number increases by 6. For manganese, oxidation number decreases by 2. That is the second step. That step is very important. If you fail to determine this change, the remaining step will fail, or the remaining step will be wrong. Okay, then third one. Multiply with a suitable coefficient in order to make equal changes. That means the increase and the decrease in the oxidation number must be equal. Once again, the increase and the decrease in the oxidation number must be equal. We multiply with a suitable coefficient. 6 and 3. LCM is 6. How to make 3 into 6? By multiplying 2. And you remember, just keep it in your minds. Okay, 3 becomes 6 by multiplying 2. So the equation MnO4 minus, multiply this reaction with the 2. So 2 MnO4, 2 MnO4 minus plus Br minus gives MnO2 plus BrO3 minus. Are you clear? If you want, you can write the oxidation state also, plus 7. The change is enough, plus 4, plus 5. Other atom oxidation number didn't change. Then the fourth step, what is the fourth step? Balance the atom other than oxygen and hydrogen. So 2 MnO4 minus plus Br minus gives. Here 2 manganese. There is 1 manganese. To make manganese in equal number, multiply with 2. Bromine is 1. There is bromine 1 number. Bromine is equal. And the fifth step, balance the oxygen atom. Balancing the oxygen atom. So 2 MnO4 minus plus Br minus gives. So here 4 oxygen, here 2 into 2, 4 plus 3, 7 oxygen. Okay, 7 oxygen molecule in the reaction. MnO4 minus, so here 2 into 2, 4 plus 3, 7 oxygen. How many difference in the oxygen? It is 3. So 3H2, you add 3H2 in this side plus 3H2. Sorry. 2 into 4, 8. Sorry, one step. 2 we forgot. 2 into 4, 8 oxygen. 2 into 2, 4 plus 3, 7 oxygen. Oxygen is deficient in the right side. So 2 MnO2 plus BrO3 minus plus H2. Oxygen is deficient in the right side. Earlier we didn't consider these two. Okay, so 2 into 4, 8. 2 into 4 plus 3, 7. 1 is deficient in the right side. So oxygen is balanced. And the sixth step. What is the sixth step? Balance the hydrogen. For balancing the hydrogen, we consider the medium. In acidic medium, it is very easy. H plus added in the deficient side of the hydrogen atom. But in basic medium, the rule is add appropriate number of water molecule in the deficient side of hydrogen. At the same time, you add equal number of OH minus on the other side. So here there is no hydrogen. Here 2 hydrogen is there. So we must add 2 water molecule in the deficient side of hydrogen. So 2MnO4 minus plus Br minus plus 2H2O. Because 2 hydrogen in the right side. The 2 hydrogen is compensated by addition of 2 water molecule. Then 2MnO2 plus BrO3 minus plus H2O. When you add H2O for balancing hydrogen, equal number of OH minus is added on the other side. This H2O is for balancing oxygen atom. Then this H2O is for balancing hydrogen atom. That is comes in the sixth step. Then if here we added 2 H2O, you must add 2 OH in the opposite side or other side. Then water is common. Okay, the left hand side and right hand side water is there. So one water molecule is removed. You write H2O. Or you just keep it in your mind. Then finally the balanced equation is 2MnO4 minus plus Br minus plus H2O gives 2MnO2 plus BrO3 minus plus H2O is removed plus 2OH minus. Are you clear? So this is the various steps involved in the balancing the equation. When we are balancing the equation in a basic medium, you just take care. Because in the deficient side of hydrogen, you must add appropriate number of water. At the same time, you add equal number of OH minus ion on the other side. If you add water in the right side, you add equal number of OH in the left hand side. That's a rule. And the second method is half reaction method. We will discuss examples for half reaction method in the next session. Rules are same. So you should memorize, you should study the rules. And the difference is the whole equation is divided into 2 half reactions. That's the difference. And the 2 half reactions are balanced one by one. Finally, we add these 2 reactions. These 2 half reactions, we will get the whole equation. So balancing by half reaction method, the same as oxidation number method. The difference is we write the skeletal equation, write the oxidation number, then we divide the equation into 2 half reactions. That's why the method is known as half reaction method. And balance the 2 half reaction, oxidation and reduction reaction. Finally, we balance the 2 half reaction must be added. So we will discuss the examples in the next section. Thank you.